This lesson is about symmetry. There's two types of symmetry. This is where you'll take your notes from that you will need about symmetry. There's two types of symmetry that you need to know about. One is line symmetry. A figure has line symmetry if it can be folded into two congruent parts that fit on top of each other exactly. Congruent, meaning the same or equal, and the big important thing to remember is it has to fit on top of each other exactly. Cover up each other's sides with nothing sticking out or overlapping. The fold line is called the line of symmetry. A figure can have more than one line of symmetry. This trapezoid has one line of symmetry going down the center right here. Now a square has four lines of symmetry, one going down the middle here, one going this way, and then the two diagonals. So that's four lines of symmetry. This one, there's no line that I can draw. There's no line that I could draw that will be the same on both sides of the line. Now, rotational symmetry is a figure that has rotational symmetry if it rotates onto itself in less than one full rotation. So in this case, this is a diamond or a rhombus. As I rotate it, you can see that it matches up with itself as I rotate it. So that's here as I go, start at this starting point. I turn it this way. As I rotate it, it covers itself up completely. That's one. This one doesn't work right there. There's no symmetry there because it doesn't cover it up completely. Here. So if it starts here, we have no symmetry because it's not covering it up. One rotational symmetry at 180 degrees. Again, none here. And there. Now it can be less than 90 degrees if it has to be at any point in time. Here, we have this arrow. That's if I rotate it. As I'm moving, I don't see it covering itself up except for there. Now it's covering itself up, so it has rotational symmetry. Trapezoid here does not. As I rotate it, you notice that it keeps going at no point until it gets back all the way around to a circle does it cover itself up again. So this trapezoid does not have rotational symmetry. So we're going to look at these different shapes. Tell me which ones you think about right now. Point out the ones that you think have rotational symmetry. So which one can I put this line through in any direction and it would separate it into two equal parts? Well, let's look at the star. Can I put this line somewhere? Go this way. Put this line here. Now is it equal on both sides? And the answer is yes, it is. This triangle also has this line of symmetry. The diamond also, the diamond also has line symmetry here. The X also has line symmetry here. The circle has line symmetry here. It also has line symmetry in any direction. Circles is a special one that has a lot of lines of symmetry. Here a check mark does not. It doesn't matter which way I put it. I could put it this way. I could move it this one over. Put it this way. There's no line that I can draw where it's exactly the same on both sides. Remember, a shape could have more than one line of symmetry. This one has one this way and also this way. circle has many lines. Any line that I put, should say any diameter, basically any line going through the whole circle would make it a line of symmetry. Rotational symmetry again, let's look at this. I turn it, that's 90 degrees. Now symmetry, 180 degrees symmetry. Again there, so this has 1 point of rotational symmetry. Pentagon turns, no point will it overlap itself until I get all the way back around. If you remember, this is called a parallelogram. Rotate it 90, 180, oop, there it does, matches itself. So 180 degrees rotational symmetry. No, so one set of rotational symmetry. This star, make sure we're starting where we need to start. Let's cover it all up like it's supposed to be. As I rotate it, so far this star is not a great example of rotational symmetry, because it's not until I get back to the very beginning does it look exactly the same. So the star has to be a perfect star with everything perfectly aligning. So it depends on the star whether if it's rotational symmetry or not. As I turn this, you can see this is a rectangle. So if I start here, I rotate, yep, there's one. That's a half a turn, 180 degrees. Turn fully back, so 1 rotational symmetry. So let's look at these letters, and as I put them up, why don't you think about yourself where I should put this? So I have an N. Should it go in line symmetry? Line symmetry. Can I draw a line on this N where it's the same on both sides? And the answer is no. How about the Z? Nope. Q? Oh, it should have went to the no. I got close, I guess. J? Nope. P? What do you think? Nope. F? Nope. R? No line there either. L? Nope. U? Yes, U does have line symmetry. H right here, right down the center of that H. Line symmetry. O, just like a circle, so yes. D actually does this way. If I would do the line going this way, it would. T, yes. If I divided T in half down the middle this way, it would have line symmetry. E also would be down the middle this way. M down the middle right here in the middle of the M would give it line symmetry. A also does have line symmetry. What about rotational symmetry here? Let's look at the X. Can I rotate the X to land on itself again? The answer is yes. Yes for an O. An O twice. X same twice. How about an H? If I flip the H around, is there a way to make it look like an H again? And the answer is yes, the capital H anyway. We've done X already. We've done H already. We've done O already. What about E? Is there a way to make this E look like an E again? Capital E? By rotating it? The answer is no. L? Right here? Yep. C? Nope. G? Nope. B? No. D? Nope. Cannot rotate onto itself. Last one, F, is no. So just remember that a figure has line symmetry if it can be folded into two congruent parts that fit on top of each other exactly. The fold line is called the line of symmetry. A figure can have more than one line of symmetry. A figure has rotational symmetry if it rotates onto itself in less than a full rotation. That is the end of your notes. You most likely should have just filled in the blanks. That's all you need to know for rotational and line symmetry. Go on to the next tile.